Thank you. So my interest is in technology and innovating technology into the environmental space. And so we've done a lot of work around water testing and data collection in that space. And a lot of that technology we've developed is also very usable in the Manuka space as well. So I just want to go over just some of those things that are out there and are available, and some of the things that we're looking at developing. So technology will make a big difference in the way apiarists manage their hives. It makes a big difference also if you have a plantation of Manuka and how you'll manage those trees. And also that technology has to be integrated. It's got to go somewhere. You've got to get that data and it's got to go somewhere. And how does that happen? So just going into looking at what we can do in hives. So it's very, very easy to use off-the-shelf technology that's out there now that agricultural industry uses. So things like measuring temperature, moisture, humidity, those sort of things are readily available now. We would also be looking at, and we are looking at developing the small microphones that go into hives that record what's going on in there and the frequencies that the bees are generating in a hive. And that tells us a lot about what's actually going on in the hive. We will run algorithms through that identify those noises, and it's not too far-fetched to think that you'll just get a message on your cell phone that goes, hey, hive number such and such, there's a warning, go and check it out. So those types of things we see are coming in now. And I don't know a lot about apiary management. I'm pretty much involved in the whole technology sphere, but from what I know from talking to other beekeepers is that they tend to work on a loss basis at the moment, and that is they oversupply hives knowing that they're going to get a certain amount of hives will die off and others will be very, very healthy. And so what we're looking at is managing without loss and managing to the optimum, and that's what technology will allow us to do, is manage to that absolute optimum potential of your hives and your trees. So we can measure humidity, we can also measure the weight in the hive. So we know, you'll be able to know then, okay, how much honey is actually being loaded into that hive? What are the bees doing? Have you got a weak hive? Have you got a strong hive? Are they collecting a lot of honey? Is there a strong nectar flow happening? Or maybe there's not, maybe you need to move your hive, it might be in the wrong position. So just being able to measure the weight in the hive will give you a lot of information as well. I also hope to be able to develop other devices that will measure just how much honey flow or nectar flow is coming in at any one time. So the whole idea of this technology is to give you real-time data as well. This is data that you're not waiting to come in or that comes in once a week or once a day. This is real-time. This is actually as it's happening, and you'll be able to gather that data as it's happening very, very, very easily. And then of course the sound, which is one which I touched on earlier. So what happens with this data? So we've got these instruments in a hive. How do we get that data out of the hive? So Wi-Fi technology is one of the ways. So that can be collected very, very easy just via Wi-Fi connection or cellular phone connection. If you're actually in an area that you've got good cellular connection, all that data can be uploaded straight away to a website or to your email address or something like that. If you're in areas which are very, very isolated and you don't have good cellular connection, maybe you're miles away, so Wi-Fi only travels for about 100 metres, then you can get that data through what we call low wave connections. So you have micro transmitters that are transmitting the data on low wave connections to a master receiver, and that master receiver is then connected to the network. Now also too, because we work in a lot of very isolated areas with measuring water quality, drones are another way that you can upload that Wi-Fi data. So you can, the chips that are in the hive, or the chips that we use, are very, very small, so you're looking at a device about that size sitting in a hive, and so a drone could quite easily fly over those hive sites and upload that data and then bring it back to home, and so you can get it that way. Another way is that you can go around with your cell phone and actually just get the data straight off the hive with a Wi-Fi connection on your cell phone or your portable device. Now, looking at Plantation Manuka, and also too if you're operating it with on sites where you're looking at getting a crop off wild plantations, how do you actually know what's going on? You might drive around it and you can see the trees, or get up on a high point and you have a bit of a look. But a bird's eye view is the best way to do it. And that's why we end up with one of these devices. I can see these being in every beekeeper's toolkit. Now I'll open this up and I'll show you what it is. $1,700, it's the latest drone out from DJI. So these little devices will fly for 7 kilometres. They are fully programmable to fly GPS programmed coordinates. And all they do is just fold out, put your propellers on the end of that. You've got your controller there, and next thing you're in the air. It's got a very, very high fidelity camera on a gimbal here. So basically what you're doing with a device like this is you're using it as a survey tool. So mapping what is happening with your plantation is very, very important. So how do you know when that nectar flow is really going to come on? How do you know what is actually happening out there with the flowering of your trees? And the only way you can really get a good idea of what is going on is with an aerial view. Now, coupled with just your raw footage coming off this, you've got to then run software to give you some determination of what's going on. So again, it's an algorithmic software that would run against the footage that you're taking, and it would tell you basically how much flour is on there. You'll be able to see, it will actually store that data too, so that then in other years it's a self-learning type of program where it goes, hang on a minute, we know that once flowering reaches a certain point, that's when our main nectar flow is coming on. And so as your algorithm data starts to learn all those things about your block, it'll start to give you a whole lot of information as to when to put your bees in, when to take them out, and also where to put them is another really important part. So getting that bird's eye view gives you a whole lot of information around that. Now if we want to take that further than just a simple $1,700 drone, you can get into some very, very, very high, quite expensive kit, which is running thermal imaging types of cameras or spectrometer cameras that are sort of $150,000 kits. But again, some of the information that you can get off those types of cameras is extraordinary. It's really extraordinary, and it's been used in agriculture all the time now, starting in New Zealand, but predominantly in Britain and Europe. All the big farmers there, all the big cropping farmers are using thermal imaging camera information. So they'll go and hire companies to do the flyovers and give them that information. It tells them all the growth rates, it tells them a lot of information actually, the amount of moisture in their soil, the growth rates of their crop, how much the yield they're going to get. So they've got algorithms that will run against all this information coming from the cameras and spit out all that data for them. And I can see the same thing happening in the Manuka industry, where you really need to know what's going on down there in that flowering period particularly. But I mean, let's extrapolate that even further. What about the health of your trees? You know, they're the things that are producing the nectar. So building up data with with flyovers, with these sort of cameras, can give you a lot of information too about the health of your trees. I mean, what about myrtle rust? Maybe, you know, this could be a great tool in measuring or mitigating that potential threat. But without that visual, that bird's eye view, it's very, very, very difficult to get it. So basically this is allowing you to be a bee, flying around and checking out your crop. Boundaries, another really important thing. You know, it's a major problem in the industry now with boundary riders and people coming and putting hives in and poaching. So doing a flyover once a day, you would see if someone sneaked in the back and put something there, and it gives you a chance then to go and say, hey mate, you know, what's going on here? Whereas you may not find out, perhaps until, if you didn't have a drone flyover, you may not find out until it's too late. until the honey flow is finished. GPSing, again, being able to really look at where your optimum sites are for bee placement and being able to GPS those sites and monitor them over time. So, you know, everything, you're trying to improve your management practices all the time. So being able to collect data and then modify your practice with that data over time will allow you to refine all your management practices and really get your optimum sites. Again, weather data on top of that has a big influence as well. So software can be written that will overlay all these sorts of scenarios to give you the management information that you want. And optics, well, I spoke about optics just before with, you know, thermal imaging and spectrometer cameras, and just that the information that you can actually get from those sorts of devices. Now, what we've got here, of course, is that we've got a situation now where a lot of hardware is already out there. It's been built and being developed, and it's been developed for other industries. But what hasn't been developed yet is the software to run that hardware so that it's actually specific for the Manuka honey industry. And it's a supply and demand situation. So as demand for intensive management increases, then the supply of these software packages will start to come onto the market. And I work with Victoria University in the School of Engineering and Computer Science, and we're constantly writing software packages to be used in the agricultural and horticultural area now. They're becoming more and more prominent because people are needing to manage their resource a lot better because of the demands of the modern world. We're having to manage these resources a lot better. So integrating all this technology and integrating all this data, it's got to go somewhere, and it's got to go to a collection point. So I just wanted to show you something that we've developed that does this. So this is a map which has been designed to take a whole lot of water quality data. So you have a whole lot of filters on it. It's a map of New Zealand, and you can zoom into any of these sites and you can zoom right up using Google Maps, and you can go right into even a 3D view of the site. It's got every river, lake and stream in New Zealand. It's the only map available online that has every river, lake and stream on it in New Zealand, funny enough. So having detailed maps like this and a collection point for your data, you'll be able to look at all your sites, you'll be able to go into specific sites, click on that site and bring up all the data from that site. You'll be able to bring up all the history from that site, and then you'll be able to move from site to site. Now, of course, a lot of this data is personal and proprietary, so you can have personal login or portals. So there might be one service that's got the whole map of New Zealand for apiarists, and then you would be going into your own personal portal, and no one would have access to that portal, and you can monitor your hives across that. This also could be really, really useful for the whole industry to get a bit of an overview of what's going on. I mean, are we getting good honey flow up north and poor honey flow over on the west coast and things like that? So as the season's going on, there could be a map that everyone can access that gives them some of that type of data. But until we actually get some of these measuring units out in the field and working, then at the moment everyone's just guessing or working in their own little bubble, and you know, some people are successful with that. But if you look at the sustainability and the longevity of this industry, then we're going to actually have to move to some of these platforms to be able to be economic and to be really good at what we do. So I'm just going to open it up now for some questions, if any of you have any questions.
So what software technology has been developed, especially regarding to the drone?
Well, with the drones, I'll talk, I can talk quite loud. So with the drones, there's been a lot of technology developed, okay? So these are, the DJIs are probably the most forward drones in the market at the moment, and probably the best units, the most economical. They're Chinese made. So this is all this technology is coming out of China. So, I mean, you can program these to fly a GPS course, so they could hover over each of your hive sites and pick up Wi-Fi connection, for instance, and actually they've got memory chips on them that would store that data and bring it back home. They've got a tracking device on them. So you can set the tracking and it will fly alongside a person walking or something like that. So let's think even a little bit more forward. Could it track bees? Quite possibly. It just needs someone to say, well, look, we've got a use for that, and they'll design it. Yes?
Sorry, did you say that you have the resolution to be able to identify bees
Yes.
with that drone?
Yes. Yeah, so these drones have very, very high, this little $1,700 one has a very, very high resolution camera, and it would allow you to do that. A bee, yeah. Yeah.
So
We don't know how it affects the bees, whether the bees like these things flying around yet. That's the other thing.
what distance does it have to be away from the bees to detect?
You could probably be about 10 metres above it. Yep.
And so is that going to be your measure of nectar flow? Because you're not going to be able to see nectar flow in flowers.
No, but of course with nectar flow, and I mean, my guess is using thermal imaging cameras and spectrometer cameras that we would actually be able to gauge what's going on with nectar flow, what's going on with flowers. I'm not 100% sure of that, but I know the way we use it in crops, and we're using it in field crops and grain crops, and it's picking up the reflective ultraviolet rays coming off those crops. So it's working, these cameras are working in specific light wavelengths. So once we identify the wavelength of light that would come off a Manuka flower, that would give us that information, then we can use the camera to actually give us that type of information, because we have to, it just be a matter of identifying the wavelength. So every plant gives off a wavelength with reflective light, and it changes as they go through a cropping cycle. So as the plant grows and changes and goes through from just growing in a vegetative state through to a flowering state, the wavelength that is reflected off that changes, and that's what the cameras pick up.
I can see it with the flowers, but what I'm thinking might be more rapid and more accurate and reliable would be if you have a lot of bees there, you know you've got honey flow.
Exactly.
And that would be your measure, the number of bees buzzing.
Yeah. So I mean, this is all very, very new application, and there is an experimentation process that would occur. But I think the exciting thing for me is that the expensive part, which is the hardware, is actually out there being used, and it's been proven. It's very robust. We know it works really well. So it's just a matter then of experimentation and software to actually bring that into the industry. Yeah, yeah. But I mean, what excites me the most is being able to be really accurate. I like, when is the honey flow starting? When is it finishing? Because we know in the wild crop, the biggest problem is dilution. So if you can mitigate that dilution factor by getting your bees in at the right time and out at the right time, then you're going to increase your profit margin quite substantially. If you're going to be able to monitor your hives so you're not putting hives in saying, well, I'm going to lose 10% of my hives because I'm just going to overpopulate and manage it that way, then you're also going to increase your profit margin if you're not losing hives. As every hive is going to be a very productive hive, then we're going to get more profit out of what we're doing. So, and also too, the amount of time that's spent just driving around, you know, like the beekeepers going from hive to hive to hive when they might open the top of one hive and, oh, there's nothing to do there. There's, you know, they have a bit of a look around and the honey flow hasn't started yet. They go to another hive and it might be full on. So being able to have some measurement happening within hives so that you're not wasting all this time going around and making the human input, the labour input, a lot more efficient. I think there's a lot of progress we can make there.
How many hives would you have per hectare?
Well, I mean, the debate's around between 1 and 2 hives per hectare. And you're looking at a 20 hectare site as being really your, that's probably the minimum site because of the flight radius of your bees. So, but if you had 1,000 hectare of plantation Manuka, that's going to be a lot harder to get around and check. And this is where some of these technologies mean that you could actually do that very, very well without having to get a whole lot of extra staff in to help you do it.
How many years does it take for the Manuka to get to the commercial stage?
Well, these guys have been talking about it early on. I think we're looking at probably around about 7 years. Yeah. To achieve getting a really substantial nectar flow. I know there's a lot of trees that are doing quite, they start to flower really well at about year 3, but every site's different. The trees, you're dealing with nature, so it's variable from place to place. Yeah.
You said that it's capable of flying 7 kilometres.
Yeah.
On a fully charged battery, how long would that last in terms of minutes or hours?
30 minutes.
30 minutes.
Yeah. Yeah. 30 minutes. Yes.
What is the difference between Manuka in Australia and Manuka in New Zealand?
I can't answer that, I'm sorry. I don't know enough about the plants to answer that. All I know is that I believe in New Zealand, and someone else might be able to help me with this, the difference between Manuka in New Zealand and Manuka in Australia.
I mean, they're different species, but it would be the same family. There are 3 main types here in New Zealand. There's Incarnum, Scoharium, and Linifolia. It's most similar to the Tasmanian variety that's in Australia.
So,
Yes.
if you're surveying a new piece of land, is
Yep.
the technology written to be able to identify the different species of trees on that land, or is that something that's still...
No, it's a very good point. Technology is out there now to do farm mosaics. We do them all the time. And what we use for a farm mosaic is one of these. Now, we can also get in New Zealand now really good satellite imagery. It's a user-pays service. But that satellite imagery won't give you the detail that you might need for a farm mosaic. So a fly-through with one of these identifies the good sites, the bad sites, also helps you identify what's actually there at the moment. The other good thing about going in first and using aerial surveillance with a drone is site preparation. So where's your water? Bees need water. Where's your water on the site? Which areas get good sunlight, which don't get good sunlight? Which areas, when you're planting trees for bees, which areas will suit better trees and won't? And so we build farm mosaics from a visual map that's produced through one of these. And that farm mosaic then gives you those really specific areas for planting rather than just doing guesswork. Because often we find that people go in with guesswork and they're replanting or changing it around at about year 5 or 7 because they've made mistakes. So this helps you do those plans right, very, very accurately right at the very start and save making mistakes like that. We can also, another bit of technology which my company is developing is a technology called photogrammetry. Photogrammetry is used a lot at the moment in surveying, and we're developing that to get a lot more accuracy out of it. So photogrammetry basically means that with a flyover with a normal 2D camera, this photogrammetry software will turn that into a 3D asset. So you'll be able to see height and depth, and you can actually build a 3D mosaic up. So again, with looking at surveying a site, you can go in and you can get a 3D view of your site as well, not just this 2D overview. And that's extremely helpful, particularly when you're looking at topography and how that influences your planting decisions and where you're going with that. Pest control is another one, and it's something a lot of people forget about. And again, a drone will give you a huge amount of coverage and identification with pest control that you won't get if you're just walking around or driving around. So it's one of those really useful tools that collect a whole lot of information that would take you normally a lot of time to do. You can do probably in 1/10 of the time with a drone. And they're not very hard to fly either. So these things, The technology in these now has been developed so well, they call it fly-by-wire technology, so it's got a whole lot of inputs in here, so when you move the levers, the thing just doesn't flop all over the place. It automatically adjusts for crosswind or headwind or barometric pressure and all these other things that you have to know as a pilot. The fly-by-wire technology does all those adjustments for you, and then when you fold this out, your cell phone camera goes in there, or your cell phone goes in there, your portable device clips on, gives you first person view. Flying around and you can see what it's looking at. So at the moment this will work 7 kilometres, you'll get first person view. If you get behind a hill, of course you won't, it relies a lot on line of sight. I get into trouble a lot with CAA because they don't like me flying out of line of sight. But we're getting there now. Those regulations will be they'll be relaxed a lot because there's been a lot of negative publicity about drones with people just being stupid where they're flying them. So basically the rules are as long as you fly under 100 metres, 400 feet, and you get permission from the landowner, you can fly out of line of sight. However, it would pay, if you were doing that regularly, to put a NOTAM, what they call a pilot's NOTAM, into your local control tower or aerodrome, just to let them know that you've got a drone flying around at a particular time that day, just in case the top dresser comes through or something like that. Then we have the other problems where top dressers don't file NOTAMs, so sometimes the tower doesn't even know the top dresser's there, they just got their head out the window and they're flying along. So, but the thing is with these drones, they are, you do have to respect them. You do have to consider civil aviation regulations, and you do have to have, I would recommend anyone flying any of these in a commercial situation, you know, if you're just using it to survey your crop or you're using it regularly, to go to CAA and do what they call the 102 course, which basically gives you a drone pilot's license and ticks all the boxes for CAA. And all you have to do for that is you learn a little bit about the legalities around flying and how to monitor the radio frequencies and how to put in NOTAMs and things like that. But look, they're an invaluable tool, and when we're looking at setting up some large areas, particularly and if they're really rugged areas, you cannot do without these. These tools are invaluable.